Before starting this video, let me tell you, if you have any doubt regarding this problem or any problem in this long challenge, you can ping me up on Instagram or you can join my Discord server. I will provide both the links in the comment section. I will pin them. So in this video, I'm going to discuss this asymmetric swaps problem which occurred in today's January CODECHEF long challenge. It is given that you're given a number n. Okay, 1 second. Let me focus it. So you're given a number n and an array, first array of size n. Why didn't it get focused? And a array of size n and another array of size n. You can swap elements between them of any position, and what you have to do is to minimize the difference between the maximum and minimum element in the first array. Okay, like let's say for 2 1 3 and 1 4 1. Okay, so 2 1 3 and 1 4 1, we can swap these. Okay, so it becomes 1 1 3 and 2 4 1, and then swap these, so it becomes 1 1 1 2 4 3. Now check in this array, the minimum is 1 and the maximum is 1. Minus is equal to 0, and 0 is the minimum possible number that is possible. Okay, minimum possible number for the solution. Okay, so this is basically what the question demands. Now the most simple approach, because of the constraints I have seen, so that would be to make an array of size 2n, 2 into n. Okay, and then take the inputs I less than n, I plus plus, ARR of I. Okay, first take this inputs and then run a loop from I, again I equals to, now I is equals to n, to I less than 2 into n, and input ARR of I. That is, we are going to basically merge both the arrays in a new array called ARR. Okay, so once we are done with this, so now we are going to do, that is, sort arrays, sort ARR. Okay, that is, we are going to sort ARR, and once we are done with this, we will, let's say, int minimum is equal to ARR of n minus 1, 2 into n minus 1 minus ARR of 0, because this is the maximum and the minimum, the difference between the maximum and minimum element among the all elements of the array. Okay, among A and B, that is, let's say if this is A and this is B, then among all the elements, the greatest is 6 and the smallest is 1, so minimum will be 5 for the initial case. Okay, then we run a loop from I is equals to 0, I is less than equal to n, I plus plus, and minimum is equals to minimum of minimum and ARR I plus n minus 1 minus ARR of I. Okay, and then we print minimum. So this is basically the sliding window type of concept. Like, let's say for this one, 2 1 3 1 4 1, if we merge them, so 2 1 3 1 4 1, then what we are going to do, we are going to sort it. Okay, 1 1 1 2 3 4, right? And then what we are going to do, we have to select all the possible arrays of size n. That is, there is one array, this one is one array, then this is another array, this is another array, this is another array, and this is another array. Okay, all of them are of size 3, and for every element we are going to subtract the first element from the last element, because the last element is the maximum of that sub array and the first element is the minimum. So every time we do that, and basically the answer, so after doing all these operations, we find what is the minimum one and we are going to print it. Okay, so over here, see, 1 minus 1 is 0, and 2 minus 1, that is 1, 3 minus 1 is 2, and 4 minus 2 is 2. So the minimum of 0, 1, 2 and 2 is 0. Okay, so let's say for this case, 2 1 4 3 3 2 6 2. So if we sort them, it becomes 1 2 2 3 3 4. So 1 2 2. Okay, there are 3 2s, 2 2 2, and then 3 3, and 4 and 6. Okay, 4 and 6. Okay, now it is of length 4, so 1 and 2 is first compared. 2 minus 1 is 1. Then we compare 2 and 3, that is 3 minus 2 is 1 again. Then we compare 3 and 2, so 3 minus 2 is now 1 again. Then we compare 4 and this 2. Okay, this 2, like, am I doing it right? 1 and this 2, then 2 and 3, then this 2 and 3, and then 4 and 2, right? So now we are going to do 4 and 2, and 4 and 2 gives us 2, and 3 and 2 gives us 1. So the minimum among all of them is 1. Okay, let me do it again. Okay, so this is one sliding window, so this is 2 minus 1 is 1. Then this is another sliding window, so 3 minus 2 is 1. This is another sliding window, 3 minus 2 is 1. This is another sliding window, 4 minus 2 is 2. So these are the possible values, and the minimum of them is 1. So for this case also, if you can check them. Okay, it becomes 2 4 4, sorry, 3 4 4, 3 4 4, then 6 is there, then 7 7, okay, 7 7, and 8 8. Okay, 8 8. Now the length is 5, right? So first sliding window would be this one. 6 minus 2 is 4. Then we check 7 and 3. So 7 minus 3 becomes 4 again. Now 7 minus 4, that is 3. Then 8 minus 4, now that is 4. And then 8 minus 6, that is 2. Now the minimum is 2. So we print 2, we print 1 for this, and we print 0 for this. So this is basically the code for this whole thing. This is a very nice problem which occurred in this long challenge. I hope you enjoyed it. Thank you.